This experiment is going to show the conservation of energy using an Airtrack. This uses the exact same setup that we use to measure the average speed of the glider. But this time we will use it to show that as the glider gains speed and hence kinetic energy, it loses potential energy as its height decreases. With some careful measurements, we should be able to show that the energy gained by the glider speeding up is the same as the energy lost by its descent. The potential energy of an object through gravity is given by mgh, and the kinetic energy of an object is given by half mv squared. We will be equating the kinetic energy gained to the potential energy lost. The first thing we need to do is raise the track at one end. You can see here that we have a ruler. You can get level with it, and this is the bit that you will read here, and we can raise this. You want to raise it quite a bit, but not enough so that the glider starts moving without the pump being on, otherwise you won't be able to control it. So you need to carefully measure that. Now we want to position ourselves conveniently. We want the glider a little bit further along, so I'll let that slide down a bit. Here we want to put the pointer at its start position. So using the mouse wheel as normal, we move things around, rotate things or whatever. This allows us to adjust things, and you can get a good reading for that by zooming in using the plus key and the minus key to zoom out. Now, the same as in other experiments, we're going to need to measure the velocity at the two positions of the timer gates. So we need delta t for the time between, and then we need to use the independent timers to get a velocity at each of these. So we'll start off by switching the timer on, making sure it's paired, see the green light come on, and then we'll time it going through both. So there it goes, the timer starts as it goes through the first, and it stops as it goes through the second. So you need to take note of that, 5.459. Switch that off. We want to bring the glider back to where it was. A little impulse, send it on its way, switch that off, and just careful use of the pump, we can get it back into the same position. Now by clicking on the cube, we'll swap to the independent timers. Switch both of these on. We make sure it's not in any kind of paired mode, and then we want the time taken through each, which will give us the velocity at each of these positions. So now we have the ability to calculate the kinetic energy through here and the kinetic energy as it goes through here. So we've got the change in kinetic energy, and using a simple piece of geometry we can calculate the height difference between the position here and the position there. And in order to be able to calculate that, you need to know exactly where the two photogate timers are, which you can use from the midpoint of the shadow for each of them, and you'll also need to know the amount that you've raised the track by. Okay, that's you need to repeat that for different amounts of the track raised, fill in the table as given in the notes, and then you'll be in a position to calculate the loss of potential energy between the two timers and the gain in velocity, and hence the gain in kinetic energy as it goes from the left hand timer to the right hand timer. Okay.